Just what we had done or discussed was we had talked about so 1 second, let me add people. So what we had talked about was that transition metals quickly they were basically any element that could form a stable ion, and it is going to have incomplete incomplete d subshells. That's what a transition metal is. And remember, transition metal, the block over here is a D block. These are D block elements. Some elements, or a lot of elements over here are known as transition metals because they have certain properties. And those properties are these, the ones that are given over here: high density, high melting points, high boiling points, colored complexes, etc. Now, we talked last time, we talked about high melting and boiling points and high density compared to calcium. I told you that when you move to the right of the periodic table, what happens is that you have more protons. Calcium, they have the same number of shells. The electronic configuration is exactly the same. The outermost for a transition metal is also 4s2. The outermost for calcium is also 4s2. But the thing is that iron has more protons, so there's more attraction, which leads to a smaller ionic radius. When you move to the right, the size of the ion becomes smaller. And you've got higher charge density as well, because iron can lose electrons, a lot more electrons. Why? Because compared to calcium, iron has this. Calcium does not have electrons in its 3D subshell. So when electrons are lost from the 4s, it's a lot harder to remove electrons from the 3p. While in iron, when electrons are lost from the 4s, it's got a 3D subshell which has very similar energy levels. So electrons could also be lost from this subshell as well. So iron can have a higher charge, and it can also have more delocalized electrons as well. So this is what we discussed, that you got more delocalized electrons and you got smaller ions, and you got a higher charge density, which leads to a stronger metallic bond when it comes to iron compared to calcium, which is why they have high melting and boiling points. Or kya tha, we also talked about them having high densities as well. Why? Because they've got a higher mass. They're smaller, plus they've got a larger mass as well. So that's why transition metals tend to have higher densities as well. And we talked about them having variable oxidation states as well. So ये सब हमने discuss किया था, right की तरफ they become smaller. The thing that we were talking about was good catalyst, and we talked about in the last class we talked about the heterogeneous catalyst mechanism, which is that I explained to you that why are they good catalysts? Because they've got a higher number of protons, so they have a very weak tendency to actually lose electrons. Instead, they slightly like to attract electrons. When you are a metal, you like to lose electrons. When you're a non-metal, you like to gain electrons. When you're a transition metal, you're somewhere in between. So you've got this weak tendency, or a very weak attraction for electrons. And that weak attraction is very helpful when it comes to acting as catalyst. So last class, we talked about heterogeneous catalyst, which is that if you've got a triple bond, it's very hard to break the triple bond. But if you have an iron catalyst, the iron has this weak attraction for electrons. So what it does is that the triple bonded electrons, they get attracted to iron, and there's a very weak bond that is formed, and that's known as adsorption. And this weak bond breaks very easily. So in this way, because iron wasn't strongly attracting those electrons, unlike a non-metal, so a very weak bond was formed, and that bond would break very, very easily. But in this process, the triple bond would either weaken or would break completely. So that is how adsorption and deadsorption, there were two processes which would help reactant molecules break the old bonds. Because the problem with every reaction is that the old bonds are really hard to break. So a catalyst in this way helps to reduce the activation energy. Okay, so I guess this is all that we did in the last class. Okay, so यहाँ तक सारा clear? Is this all clear? ठीक है, Sana, is this clear? Sidra,
Yes, sir.
अच्छा. So, we're going to move towards the other catalyst example as well, and that's homogeneous catalyst. Okay, so we're going to do one example for that as well. Just 1 second, let me start on that. So the homogeneous catalyst example. Now, this is one very specific example that you need to learn. So homogeneous catalyst, what does it do? Firstly, that's a catalyst where the state of the catalyst and the reactant molecules, they have the same phase. So catalyst and your reactants have the same state of phase. So there are plenty of examples of homogeneous catalysts. One example is that in the formation of acid rain, the NO2 molecule acts as a homogeneous catalyst. What it does is that it goes and reacts with NO2 goes and reacts with SO2, turns it into SO3, oxidizes it, gets reduced in the process, and at the same time, the same NO then reacts with oxygen. And when it reacts with O2, it turns back into NO2. So it remains unchanged. So what happened over here is that you started off with that you started off with NO2, and eventually you got NO2 back again. So that's an example. That's one example of a homogeneous catalyst. But that obviously does not involve. It doesn't involve transition metals. So we need to be transition metal specific. So one example for that is, and again, the same thing over here. The thing with transition metals is that they can lose electrons, but they can also gain electrons back again. Unlike, for example, sodium. If you look at sodium cannot act as a catalyst because it can't do both things. Like if you look at the electrode potential of sodium, and if I write down the electrode potential for sodium, it's a very negative electrode potential. What that means is forward and backward. So what that means is, I mean, this electrode potential is, the E naught is minus 2.71 volts. A highly negative or a very, very low potential, TK, if you remember something about electrochemistry, a very low potential indicates that sodium likes to lose a lot of electrons, and that is the only thing. हाँ जी
सर, आपने इलेक्ट्रोकेमिस्ट्री कंप्लीट की है?
मैंने की थी, हम दोबारा कर लेंगे. इसमें थोड़ी सी आ रही है, मैं वो थोड़ा सा एक्सप्लेन कर देता हूँ, ठीक है, वेरी ब्रीफली. मतलब what is electrode potential, I'll just tell you. उसमें बस the basic idea is कि you just have to remember कि जो negative voltage है ना, low potential, that indicates that the substance really likes to lose electrons. मैं थोड़ा सा idea दे देता हूँ क्योंकि completely एक separate chapter है, but I'll just give you a very brief idea. कि imagine that you have a sodium metallic electrode, and imagine that it is placed in a solution that's made up of sodium ions. ठीक है, अब दो possibilities हैं. ठीक है, this is what an electrode actually looks like. So अभी बिल्कुल basic level के ऊपर हमने पढ़ना है, ठीक है. Nothing we're not going to go too in depth into this. So what will happen? Either sodium will lose electrons to form sodium ions. इधर अभी दो possibilities. Either sodium will lose electrons to form sodium ions, or sodium ions will gain electrons to form sodium back again. So this one, sodium क्या करेगा? Lose करेगा electrons या sodium ions electron gain करेगा? क्या करना चाहता है वो?
lose.
lose karna chahta hai, right? The sodium is very reactive, right? So what's going to happen over here is okay, all of a sudden sodium will start to, it's going to be a vigorous reaction. Sodium would start to lose electrons, a lot of them. So a lot of sodium ions are going to be produced. So, and if it loses electrons, the metallic rod will have a lot of extra electrons on it. वो electrons lose किए जा रहे हैं ना outer shell के, so metallic delocalized electrons, all those electrons are accumulating on the metallic rod. The metallic rod पे what charge develops on it? Negative potential, right?
Negative.
Clear है? Idea clear है ये?
Yes, sir.
अच्छा, तो अभी बिल्कुल बेसिक कि a negative potential indicates that it wants to like really lose electrons. ठीक है? A positive potential on the other hand indicates that it wants to gain electrons. अगर positive होता ना, इसका मतलब होता कि वो जो भी substance था ना, it started gaining electrons. But अगर उल्टा होता ना, like if sodium ions wanted to gain electrons, तो metallic rod से ना सारे electrons sodium ions gain कर लेते हैं. तो यहाँ पे electrons खत्म हो जाते हैं और क्या charge? What charge would have built up? It would have been a positive charge, right?
So,
हाँ जी.
सर इक्विलिब्रियम में तो इसमें ले चार्ट
किसमें?
प्रिंसिपल फॉलो होगा?
नहीं क्या नहीं वो होगा. मैं कह रहा हूँ नहीं, मैं अभी मैं कह रहा हूँ डिटेल में जाने का नहीं है अभी. ठीक है, ऑल यू हैव टू डू इज कि बस ये समझो कि नेगेटिव का क्या मतलब है. वो बाकी डिस्कशन बाद में कर लेंगे टॉपिक. ठीक है, उसमें फिर डिटेल में हम डिस्कस करेंगे.
ओके सर.
ये पूरा एक बहुत बड़ा चैप्टर है. ठीक है, it's not that simple. तो उसके अंदर बहुत डिस्कशन होगी. अच्छा, but at the moment, is this point clear that if you have a negative potential, that indicates that sodium likes to like really lose electrons? Is that clear?
Yes, sir.
Yes, sir.
ठीक है. And just remember, if you have a positive potential, I mean, electrochemistry right now for you at the moment, at the very basic level, just remember this. Low potential, that means low or negative, right? So lower potential just indicates that it wants to lose electrons. That's known as E naught. That means it wants to lose electrons. And if you have a higher E naught, which is positive potential, that just means that it wants to gain electrons. Anyways, so we'll just use this concept at the moment. Okay, that's it. Okay, the rest is the whole chapter. We'll do that later. तो उसका बस थोड़ा सा पार्टनर भी यूज करना हमने. अच्छा, anyway, so there's this example. So sodium cannot be a very good catalyst because sodium will not do both things. Sodium will mostly just lose electrons. Sodium just wants to lose electrons. The good thing about transition metals is that they can kind of do both things. They're kind of in the middle. Transition metals can lose electrons and they can also gain those electrons back. ठीक है, मतलब iron है ना. If you have iron Fe can like if you have Fe2 plus, it can actually gain those electrons back and form Fe back again. Or vice versa, Fe can sometimes lose electrons as well. Or dono cheeze, it doesn't do that very strongly. Like sodium really strongly just wants to lose electrons. That's it. Transition metals, they're kind of in the middle. They will kind of do both things. Iron will lose electrons. It can also kind of gain those electrons back and form iron back again. ठीक है, so iron metal होता है ना, oxidize होता है air में. It forms rust, but that's a very slow process. It can lose electrons. And at the same time, you can convert that iron and you can reduce it back and you can turn it back into iron as well. Now, this property is like kind of really helpful when it comes to this particular example of homogeneous catalyst. So let's quickly discuss this one specific example, and you have to remember this one specific example. There's a reaction. There's I2 plus 2 electrons, and that's in equilibrium with so that's in equilibrium with 2I minus 1. And this has a potential of 0.54 volts. And similarly, I've got 1 second. So that's your iodine potential. And similarly, we've got another reaction, and this reaction is S2O2 minus plus 2 electrons, and that's in equilibrium with so 2SO4 minus 2. And that has an E naught of 2.01 volts. So which one out of the two has the higher potential? It's ये bottom wala. ठीक है, that's your higher potential. और अभी हमने क्या discuss किया था? Higher, what does the higher one want to do? It wants to gain electrons, right? And this over here is the lower one. The lower one wants to lose electrons. So the higher one wants to gain electrons. And the other one is the lower potential. So that wants to. So that one wants to lose electrons. So is this clear? कि potentials को ना आप compare करते हो. All you need to understand is that at the moment, a higher potential gains electrons and the lower potential loses electrons. If you keep the two things together, this is the one that's going to gain electrons and this is the one that's going to lose electrons. This is going to go in the backward direction. This is the one that's going to go in the forward direction. वो electron produce करेगा और उसके electrons ये gain कर लेगा, ठीक है? Because this is the higher potential. And you'll have an overall reaction which is going to be, I'm going to add up the reactants. What are my reactants? It's 2i minus 1 turning into what? It's turning into I2. Okay, so I've got my 2i minus 1 and the product that it's forming is iodine. And what is the other reactant? I've got S2O2 minus and that S2O2 minus is turning into 2SO4 2 minus. So that's your reaction that will happen when you connect these two electrodes together. Or if you just look at these two electrodes, you'll figure out that this is the reaction that will happen. Or there's a thing called E naught cell. That is the potential difference between the two electrodes. So one is the higher potential, the other one is the lower potential. जो positive वाला ना, that is the one that gains electrons. The higher one is the positive one. The lower one is referred to as the negative potential. So the higher one is the one that's going to gain electrons, and the lower one is the one that's going to lose electrons. Potential difference is over here is 2.01 minus 0.54, and that comes out to be क्या value? What's the potential difference between the two? It's 2.01 minus 0.54. And this value comes out to be 1.47 volts. Okay, that's the value that you're getting. Now this cell potential has a specific, I mean, the potential difference over here tells you how vigorous the reaction is going to be. Okay, the higher is going to attract electrons, the lower is going to lose electrons. This is the one that's going to lose electrons, produce electrons. This is the one that's going to attract electrons and gain electrons, right? Jitna zyada potential difference hoga, the faster will be the flow of electrons. There's going to be more current, right? Voltage and current, they're directly proportional. You've got a bigger voltage, the reaction is going to be faster. Electrons will flow much more quickly. ठीक है? तो E naught cell का समझ आया? Is that clear? So is this clear, Sidra? बाकी जिन्होंने नहीं किया भाई ये. Rizwan, is this clear?
Yes, sir.
Yes, sir.
So based on electrochemistry alone, again, based on the idea that the higher one wants to gain electrons, the lower one wants to lose electrons, you've got this reaction, and this is a very feasible reaction. It's a very vigorous reaction. It's got a very high voltage. But the thing is that this reaction in reality does not actually happen. And there's this reason for this. Okay, why is it not going to happen? The reason is, if you look at the two things that are reacting together, these two things, what you'll notice is that both of them have a negative charge. So in reality, although theoretically this reaction is feasible, but this reaction is going to have a very, very high activation energy. Why? Because the both ions that should be reacting together, how do they react? They're going to react when they collide with each other, right? I mean, this should react with this one, but they're not going to collide with each other because they're going to repel each other. They will never interact with each other. The negative ion over here will repel the negative ion on the other side. So there's hardly going to be any interaction between the two. And so in theory, this is a very feasible reaction. But since both ions are negative, it would be kind of very hard for them to even come close to each other, right? So idea clear why this reaction has very high activation energy?
Yes.
So to make them even meet each other, to have a collision, you would have to give them a lot of kinetic energy so that they can overcome the force of repulsion. So large kinetic energy would be needed to overcome the repulsion. So it's got a very, very high activation energy. So that's one thing. We've understood why this reaction will not happen. Now we are going to bring in the catalyst. The catalyst is going to make this reaction feasible. And this is what the catalyst will do. Okay, so idea is clear. You've got a higher potential, you've got a lower potential. That one wanted to gain electrons, this one wanted to lose electrons, but they're never going to meet each other because they're both negatively charged. So this is not going to happen in reality. And there's too much repulsion between them. So you bring in iron catalyst. So we've realized that the two species are not going to interact, right? So we're going to separate them. We're going to do this again now, but now with a catalyst. So this one is not going to interact with this one. You get this I-1 is not going to react with this one. So I've kind of separated them. There's not going to be any reaction. Now, what they do is they add a catalyst, and the catalyst in this case is iron ions. You add Fe3 plus and Fe2 plus ions. Now, the thing with iron ions is that when you add Fe3 plus Fe2 plus, there's a specific electrode which represents Fe3 plus and Fe2 plus. And it's this one. So there's this specific, and this electrode has a potential of 0.77 volts. Now, when you add iron ions to it, the iron ions are going to go and separately react with both of them. Okay, so there's this other, you've added iron ions. So the sulfate and S28 and the I-1, they were not interacting with each other, right? But as you added the iron ions, they're going to separately react with both of them. So in the first one, take a look at the first reaction. Who's the higher potential? Now there's separate reactions that are happening. The reaction has been broken down into two steps. This one is your higher E naught. Okay, that's your positive one. And this one over here is your lower E naught, the negative side. So the higher one, what did we learn? The higher one gains electrons and the lower one likes to lose electrons, right? So when the iron ions go and they interact with the I-1, the I-1 is the one that has a greater tendency to actually lose electrons. It's got a lower potential. So it loses electrons and the iron ions are able to gain those electrons. So you got this reaction going on, and we can write the overall equation in this case. The overall equation that we'll get is you have 2I-1, that's your reactant. And that 2I-1 on the other side is turning into what? It's turning into I2.
सर सर अब जो आयरन की इक्वेशन है सर अब दोनों साइड से आप टू टाइम्स से मल्टीप्लाई क्यों कर रहे हैं? लाइक क्या जरूरी होता है इस तरह से करना?
नहीं, वो अगर ना रीडॉक्स का थोड़ा सा याद है ना, वो मैंने इससे पहले ही कर दिया था। रीडॉक्स अगर
हाँ
थोड़ा
सर,
सा
तो
याद है,
लाइक
वो
इलेक्ट्रॉन्स कैंसिल हो जाएंगे।
इलेक्ट्रॉन्स कैंसिल आउट हो जाए, ठीक है। वो जैसे बैलेंसिंग नहीं होती थी, रीडॉक्स बैलेंसिंग, राइट?
यस सर।
अच्छा, एक सेकंड है मुझे। अच्छा, खैर इधर क्या हुआ है अभी ना कि you've got I-1 turning into I2, right? And what happens to the other one, Fe3 plus, or the 2Fe3 plus? That turns into what? That turns into 2Fe2 plus. Okay, so you've got a reaction going on. So as soon as you added the iron ions, you had a reaction going on, and that reaction was a lot faster. Why? Because look at the charges on the ions. One is negatively charged, the other one is positively charged. So they're going to attract each other, and they're going to react, and they will. And the I-1 being the lower potential would lose electrons, and the Fe1 being the higher potential wants to gain electrons, will gain electrons, right? So you'll have a redox reaction. Similarly, you will have a redox reaction over here as well. The iron catalyst that you've added is going to go and react with the sulfate as well. Or wahan pe, if you look over there, what is going to happen? Who's the higher potential now? The higher potential is this one. That is the positive one, and the lower potential is the bottom one. That's your negative one. So the higher one is going to gain electrons, and the lower one is going to lose electrons, right? So over here, what's going on is that S2O82 minus, that's S2O82 minus. And what is it turning into? It's turning into the product that's forming is this one, 2SO4 minus 2. So what about the other one, the 2Fe2 plus? And the product it's forming is 2Fe3 plus. So we've got our products, and and that's my second reaction. This reaction is going to be very fast as well, that both ions are oppositely charged. You've got a positive ion, you've got a negative ion. Now look at these two reactions. The ones I've written over here. If highlight this one, turning into this, and then this one, and it's turning into this thing. As I look at these two reactions, what you'll notice is that overall nothing is happening to Fe. Fe started with 3 plus, it turned into Fe2 plus. It gained electrons. But over here, that same Fe2 plus lost electrons and turned back into Fe3 plus. But at the end of the day, you got both of your products. You got iodine and you got SO4 minus 2. Okay, if I zoom out, what was supposed to be my two products? My two products were iodine and SO4 minus 2, right? So these were the two products that should have been formed. And they are actually forming, but they're forming in two steps. You had a step 1, and then you've got a step 2 as well. So the whole reaction, this is your step 2. And that over here is your step number 1. So that's your step number 1. So the whole reaction has now happened in 2 steps. And there's no activation energy needed now. Why? Because you got a super fast reaction. Positive ions attract negative ions, so there's no problem of them interacting. Even, I mean, the collisions would increase on their own. They'll just interact with each other. You don't even have to give them or increase the number of collisions. So is this clear? Example clear?
Yes, sir.
Okay, बाकियों clear? Alicia, Anna, is this clear? Umar, Shahad, Hasib, is this clear?
सर सर जो ये 2 स्टेप्स है तो उसका अल्टरनेट पाथवे टाइप हुआ ना?
हाँ, alternate pathway दे दिया उसने. ठीक है, तो यहाँ पे मैं ऐड कर लूँ कि both ions your reactants. अच्छा, both ions or reactants are negative. So both ions are oppositely charged now. पहले मसला था, they were both negative, but now both ions reactants are oppositely and attract. So if the reactants are attracting, there's obviously less activation energy needed. They'll just attract each other and they'll interact with each other all on their own. Alicia, clear? तो इसको बस देख लेना कि क्लियर है ना सारों को.
Yes, sir.
And the thing is कि why was iron such a good catalyst over here? Like sodium would have been a terrible catalyst. Why? Because sodium would only do one thing, and that is that it would, I mean, it's got a very negative potential. It just wants to lose electrons. That's it. It just wants to do that. Abhi, they'll just, I mean, the questions that you're going to get is going to be exactly this thing. It's, they'll just ask you about, transition, I'll show you. Okay, let me show you. It's going to be exactly the same. Whatever we just talked about, they're going to talk about exactly the same thing. 1 second, where's A2? Transition, कहाँ पे है? That's this one. अच्छा, इसके अंदर कहीं ना कहीं एक सेकेंड. अच्छा, sorry, images. वैसे दिखा देता दिल, अगर मिल जाए मुझे जल्दी से, वरना जब पास पेपर करेंगे ना उसमें आ जाएगा क्वेश्चन. Just a second. नहीं, एक सेकेंड, कहीं था क्वेश्चन यहाँ पे. अच्छा okay, anyways I'll just नहीं sorry अच्छा सारे हो गए. So I'll show you the questions ठीक है when I find them, but I'll explain the question. The question is simply going to be okay, they'll ask you to explain how iron ions act as a catalyst. So all you have to show them is okay, you tell them about this reaction. You just have to memorize these. I mean, it's basically at the end of the day, you have to memorize this. Okay, you're going to show you this particular reaction. That there's step 1, and then there's step 2. And this specific example, you have to tell them, and you have to explain to them that. I mean, they're going to ask you like, why does the activation energy decrease? So you're going to tell them that both of the ions were negatively charged, and now both of the ions are oppositely charged. So there's obviously lesser activation energy because they start attracting each other. So ये memorize ही करना है. It's just going to be exactly the same thing, and asking you about the whole process of how does iron ions act. ठीक है, तो आपने exactly लिखना है जो ये नजर आ रहा है. ठीक है, इसमें there's nothing. हाँ.
So तो like basically वो कभी दो negative ions दे देंगे और उससे आगे figure out करना.
नहीं, it's not going to be a random question. It's going to be very specific. It's just going to be this example. ठीक है.
Okay sir.
दो examples है heterogeneous catalyst के, sorry, homogeneous catalyst के. One of them is about the acid rain thing. You have to memorize this. सिर्फ इस पे question आएगा. हाँ, if they give you some other, अच्छा, if they give you some other वो दे देना, अगर कोई अगर दे दे तो फिर पूरा रिएक्शन वो खुद लिख के देंगे आपको, मतलब आपको सोचने की जरूरत नहीं है. ठीक है.
Okay.
नीचे मैंने इस पे बोर्ड लिंक भेज दिया. ठीक है. अच्छा, क्या तो जो नेक्स्ट क्लास में करेंगे ना, ये हमारा कैटलिस्ट वाला काम खत्म हो गया. इसका मैं फिर से एक्सप्लेन करूं. It's not just going to be any random reaction. It's going to be this specific example, only this specific example. ठीक है. हाँ, अगर कोई और हुआ ना तो they'll give you all the information, and they'll have to give you all the reaction sequences as well. तो लेकिन जो भी क्वेश्चन होगा, it's just going to be this specific, very specific example. अच्छा, next class में ना what we'll do is we'll talk about complexes. Okay, and we'll talk about complexes, and we'll talk about the reason why complexes are colored. So next class we'll talk about metal complexes. There's going to be ligand exchange. Actually, remember transition metals mein na, it's not it's like inorganic. It's mostly memorization. It's most of the stuff that you're going to be asked is going to be exactly what I'm teaching you. That's it. इधर उधर की बातें नहीं होंगी. It's just going to be the questions. Most of the questions are going to be very specific. That's it. Exact to the point. जो यहाँ पे लिखा है वो आपने पेपर में लिखना है. That's it. मतलब वो उस तरह नहीं होगा electrochemistry या मतलब it's not a conceptual topic as such. वो उसको extend करके ना they'll make different problems out of it. It's just going to be the same questions, repetitive, the same thing, the same answers being repeated over and over again. Actually, next class we'll do metal complexes. Why are they colored? There's a thing called ligand exchange. So अभी time खत्म हो गया, तो we'll do this in the next class. ठीक है, बोर्ड का लिंक मैंने शेयर कर दिया, तो ये फिर हम कल कंटिन्यू करते हैं. हाँ जी
सर, इसका लिंक तो गूगल ड्राइव में होगा ना?
ये किसका बोर्ड का लिंक?
हाँ सर, और ये जो लेक्चर का भी है ऑनलाइन.
हाँ, वो मैं फिर से भेज देता हूँ. ठीक है, उसी में होगा. चलिए ठीक है. ओके देन एवरीवन.
ओके सर, अल्लाह हाफिज़.
अल्लाह हाफिज़.